Hi, this is Andrea Kane, and I'm here with you for HIT 445, which is quality management. We are now up to chapter 5. In fact, this is week 2. We'll be covering chapters 5, 6, and 8, and 9. Chapter 5 is about aggregating and analyzing performance improvement data, and while we need to touch on this, much of this information we will get into more detail with class HIT 452, which is all about statistics and data analytics. So these two classes cross over a little bit when you're talking about performance improvement data and statistics and graphs and those types of things. So according to our syllabus, we are looking at unit objectives 9.2.4, 9.4.1 through 9.4.7, and 9.5.3 and 9.5.4. And again, we're on page 69 in your textbook if you want to follow along. According to our book, we want to make sure we know the differences between internal and external benchmarking, common healthcare data collection tools, and data aggregation when it comes to data analysis. We want to make sure that we're choosing the correct graphic presentation for a specific data type. We're probably not going to get into a whole lot of graphic displays, although you definitely need to do that, and there are some graphs that I will ask you to do throughout this course. And then analyze the data for changes in performance displayed in graphic form. So let's go ahead and get started talking about sources of data. We pull data from surveys, patient records, incident reports, employee performance evaluations, staff competency results, and many, many other places. It can come from purchasing records. It can come from cost analyses. It can come from market data about service areas and utilization of facilities and services and providers and things like that. It can come from the government. It can come from vital statistics in the area. Just a myriad of different places where it can come from. In order for us as an organization, we'll pretend we're a hospital, so to speak, or a physician clinic, we have to know how we're doing. How are we doing today? Is it better or worse than last month or last year? And where do we want to be in the future? And how does this compare to other hospitals, other clinics, other healthcare areas? That's where we get into internal and external data comparisons or benchmarking. Because it's nice to know where we're at today, but where we're at today doesn't necessarily tell us whether we're good or bad, whether we need to improve or whether we are where we need to be and we need to maintain it. You know, sometimes improving is not the hardest part. Sometimes it's when you get to that really high level, it's maintaining that high level that's a real challenge. One way that people gather data is through check sheets. They can do it through sample observations. A good example of this would be hand washing rates in a hospital or a clinic. Someone has a check sheet and they go out and they observe. Does the nurse wash or her hands, or foam in, foam out, or gel in, gel out, whatever is their sanitizing, cleansing, hand cleansing situation before they see the patient, after they see the patient. And not only is the nurse doing it, but is the doctor doing it? Or is the PA or nurse practitioner doing it? Is everybody doing hand washing? And so you have a check sheet and you stand around and you wander and you watch and you take notes as to who's doing what and when, and who missed something there, and all of that. When you're doing that, you need to consider 4 W questions. Who is going to collect the data? What data will be collected? Where will the data be collected? And when will it be collected? Are you going to collect it when there's very few patients, or are you going to collect it when you're at your busiest? Will you collect it in all areas of the clinic or one particular area? What data are you going to collect? Are you just going to do nurses, or are you going to do nurses and providers? Are you also going to do MAs? Um, all those questions. And who's going to collect the data? Is it going to be someone objective, or is it going to be someone who's going to let their buddy slip by because, well, that's their buddy? Types of data. Nominal. This is also called categorical data. And this is on the bottom of page 73 if you're looking in your book. It includes values assigned to name-specific categories. An example might be male or female. It's usually displayed on bar graphs or pie charts. And they give you an example of a bar graph at the top of page 74. It lists the ethnicity of a hospital's patients. How many discharges do they have based on patient ethnicity? Then you have at the bottom of page 74 an example of a pie chart. And this is looking at the types of patients within a hospital. Are they emergency only? Did they come through the emergency room? Are they an emergency admit? Are they an urgent admit? Maybe they were sent over from a physician's office. Are they elective? Did they schedule to come in? Is this like an orthopedic procedure that, yeah, they need it, but if they do it this week versus next week, it's not really a big deal? Are they a newborn where, they're new to your hospital? They came in inside of mom and poof, you've got new patients. Are they a delivery? Are they a mom who came in to deliver? And so it gives you that example. You also have ordinal data, which can also be called ranked data. It expresses the comparative evaluation of several characteristics or entities. An example is using a Likert scale. It's best displayed on bar graphs or pie charts. And this is described for you at the top of page 76. A Likert scale, that's the 1 to 5. I like it a 4. I like it a 3. Those types of things. Out of a 1 to 5 type of situation. And then we get into discrete or count data. These are numerical values that represent whole numbers, like number of children in a family, number of non-billable patient accounts, and those are best for bar graphs. Continuous data is just what it says it is. It can go on almost forever, an infinite number of values. Example would be weight. Someone's weight could be measured for a week. Their weight could be measured for a month. Their weight could be measured for a year, 2 years, 3 years, 5 years. Blood pressure would be another example. You could track their blood pressure over this infinite period of time. It's a finite period of time, but their blood pressure can be checked every 15 minutes, or it can be checked once an hour, or it can be checked once every 6 hours, or once every 12 hours. It just depends. Temperature's the same way. These are best displayed in histograms or line charts because they let you see it over time. The example they give is figure 5.6 on page 76 with Donna's at-home blood pressure monitoring. This is where Donna, the patient, is taking her blood pressure at home, and she's tracking the systolic in blue and the diastolic in orange. And that's where she's seeing the fluctuations. You can see it over time. And she can keep adding to the graph as much as she wants. Frequency, there's 2 types of frequency they want to talk to you about here, and it's absolute and relative. Absolute frequency is the number of times that it occurs in the data set. So, for example, they give you the data set at the bottom of page 76, table 5.1. How many times do you see 22 per minute as the respiration rate? That is an absolute frequency. You have 22 and it happens twice. You have 25, it happens 3 times. Now you've got relative frequency, and that's the percentage of time that the characteristic or score appears in the data set. So what you would do is, for instance, the 22, you would figure out what percentage of the whole that is, and that would be your relative frequency, that it occurs that percentage of time out of the whole, rather than a whole number. So absolute, they're looking for a whole number. Relative, they're looking for a percent. Use of data sets for PI purposes. Oh, mercy. We have studied this. It was it last semester in Health Information Systems? We talked about data sets, how you could go out and you could look at the ones that the government's using. The value of data sets is that they permit accurate external reporting, and they're consistent. So if you use a data set, you're collecting the same things every single time. And it helps you look at the reliability of the data, correctly interpret the data, and then again report it and feel good about what you're reporting. Data analysis. This is one thing that I think will be changing in this program over the future, that we'll be doing a lot more with data analysis, because the HIM, HIT field, this is an opportunity for us to get into that area and really showcase our skills. But data analysis is the task of transforming, summarizing, or modeling data to allow the user to make meaningful conclusions. I've talked with a couple of individuals who have transitioned out of a traditional HIT, HIM role into data analysis because of COVID. They have found that they are needed to handle the data that's specific to their very large organization as it pertains to COVID. And so I know of one individual particularly who works for the University of Iowa, who is now doing data analytics for COVID for that very large organization. So that is also an option for the future. And of course, she's working from home. Data quality. Data quality management functions include application, collection, warehousing, and analysis. And data management characteristics include accuracy, accessibility, comprehensiveness, consistency, currency, definition, granularity, precision, relevancy, and timeliness. And I hate to tell you this, but you've got to know what each one of those mean. And this is where you're going to find those definitions. Starts on page 79 and goes into page 80. So I am telling you, hint, 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 you need to know what these terms mean on this slide. So make sure you take a look. The book has some really good examples, and a figure 5.7 may be helpful to you if you're a visual person, but those definitions are there. Statistical analysis, mean, median, skewing, and standard deviation. If you are also taking HIT 452, we will get into these there, and we will actually calculate them out. They seem more intimidating than they are. So let's distill them down. Mean is the arithmetic average. What does that mean? It is the average of the value. It's the average value in a range of values. You sum all the values up and divide by the total number of values in the range. So it's, if you have, and they give you the examples. They actually walk you through this on the bottom of page 80. So I'm probably not going to get into it, but let's just say I'll write it out here so I can repeat it. But let's say you take 1, 2, 3, 4, 5. Okay, you've just got those numbers. Those are your numbers that you're dealing with, and you want to know what's the mean. Well, okay, we're going to add them up. So we add them up. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Oh, we've got 15. They total up to 15. 1, 2, 3, 4, 5 added together equal 15. We have 5 numbers, right? 1, 2, 3, 4, 5. We have 5 numbers that we're adding together. 15 divided by 5 equals 3. 3 is the arithmetic average. It's the mean. 3 is that mean. All right, now let's talk about the median. It's the middle number. 1, 2, 3, 4, 5. What's the middle number? Well, we have 5 numbers. The middle number is going to be 3. So is the mean and the median the same thing? Not in our case. The mean is 5, or I'm sorry, let me say that again. All right. Yes, in our case, the mean and the median are exactly identical. In other cases, they are not. I was looking at something else. Sorry, got distracted there. In our case, the mean, the arithmetic average, was 15 divided by 5, which was 3. In the median, the middle number is 3. 1, 2, 3, 4, 5. So for our case, the mean and the median are the same, but that may not always be the case. Skewing, if we had very high or very low values, those would distort the mean. Because, all right, let's say we had 1, 2, 3, 4, 5, and 100. Is our middle number going to be anywhere close to 3 if we have 100 after that 5? No. Our mean will be 30, and our middle number would be 3, in between 3 and 4, which I guess would be 3.5. So it's real when you have really high or really low values of your group of numbers, that's going to distort the calculated mean, and it will be called skewing. Now let's talk about standard deviation. That's the spread of values. That means how big is the gap between the very lowest and the very highest, the spread of the values, and how many are in between. So standard deviation is easily calculated, and they show you how to do it. And they walk you through how you do it through a spreadsheet. And that's probably the easiest way to do it. You may also have a calculator that allows you to do it. I will tell you, for the purposes of this class, you don't need to know how to calculate standard deviation. You just simply need to know that a lot of people like to know what the standard deviation is. They feel more comfortable knowing what the spread of values are and looking for whether or not there is a correlation based on that standard deviation. And that's where you end up going into predictive analytics. That's where you take statistical analysis and then use them to predict future events. And this is on page 83. And the rest of this looks like it's examples and case studies and review questions. So I'm going to encourage you to make sure that you do those activities. We will talk about some of these other things again in HIT 452. That's where you're going to get most of it. I just need you to know that these exist and what they are. You don't necessarily need to know how to create them, although with things like line charts and bar graphs and pie charts, those are types of things that you will probably eventually need to be able to produce. But for the purposes of today and this week's quiz, just know what they are and what they're for. And so, like, I'm going to skip through all of these slides. They're here if you want to go back to them and study those. All right, I'll be back shortly to talk to you about Chapter 6.